Hi guys, welcome back to another update on VKEngine. I'm happy to be making this devlog since I finally get to use the title. Anyway, let's go take a look at the engine. So here's what I'm currently working with. As you can see, quite a lot has changed since last time, so I'll just go through things one by one. First of all, I've added a camera system, so you can now look around with the mouse and move around with the WASD keys. Then if you want to interact with the UI, you just hit the spacebar to bring back the mouse cursor, and you can freely make changes in the user interface while the camera remains fixed in place. And once you're done setting the scene, you simply press spacebar again to return to the free camera mode. I'm also loading many duplicate instances now instead of a single model, and I'm doing this by using instance rendering to render them all with one draw call. I've tested up to 10,000 models with zero problems. You might notice that the colors of the model now look a bit different to previously, and that's because I'm no longer simply outputting the raw diffuse texture. The scene now contains a directional light that is illuminating the scene from above, and I'm using this lighting to apply the Blinn-Phong shading model. You see if I turn off all the lighting, you can still kind of see the objects, and that's because of the ambient term I've applied to just fake some indirect lighting. You can see as I move around the model, we now have view-dependent specular highlights. And I've also added some animated point lights to the scene. So if I disable the sunlight and enable them, you can see them lighting up the objects with some color. That is a red light orbiting the outside and a green light orbiting the inside. And these also mix correctly together, and they mix correctly with the white sunlight. And here are some image comparisons of the various shading techniques. So this is just the raw diffuse texture applied with no lighting. Then this is Lambertian diffuse, which darkens surfaces not directly facing the light. And this is Blinn-Phong, which has the view-dependent specular highlight. And as a bonus, here is a video I took before working on the lighting to validate that the model's normals were being output correctly. And as you can see, the y-axis is green, the x-axis is red, and the z-axis is blue, as you would expect. So I wanted to list down everything I've currently implemented in VKEngine. So right now we can load a 3D model, an OBJ file with a diffuse texture map. We can do instance rendering, which allows any amount of duplicate meshes to be rendered using one draw call. We have a free camera and a UI interaction mode with seamless toggle. The IMGO interface allows editing of dynamic pipeline states. There's dynamic lighting with directional and point lights using the Blinn-Phong shading model. And I've implemented some debugging stuff with labels and object names when I'm using RenderDoc and NVIDIA Insight. And I also have MSA and swap chain recreation for window resizing. So as for my next steps, here's my provisional roadmap divided into things I have implemented before in my OpenGL project and things that are basically new to me. So I've already done normal mapping, physically based rendering with GLTF 2.0 model and Cook Torrents GGX BRDF, and image-based lighting. So I assume it would be fairly similar to implementing Vulkan. And then things I've never touched before really include frustum culling, skeletal animations, omnidirectional shadows, cascaded shadow maps, and then more interesting transparency and deferred rendering, moving towards a tile deferred with a forward pass as a final solution probably. So here's some light implementation details. I'm using dynamic rendering and descriptor indexing to alleviate some of the hassle with descriptors on the application side. Camera data is being passed to shaders via push constants. Since Vulkan 1.4 guarantees 256 bytes or push constants, we can guarantee that's portable. And then my object model matrices and my lighting data is being stored in persistently mapped SSBOs, shader storage buffer objects. As always, thank you for watching. You can find the source code located below, as well as some resources for learning computer graphics on my personal website here. Feel free to subscribe if you want to follow along with the development of this project, since I will be posting more videos in the future. Thanks.